Hi guys, in this video I would like to go over some basic information that you will need to understand our spirometry laboratory exercise. Spirometry is a commonly used diagnostic tool for the diagnosis of pulmonary conditions that can affect a patient's breathing capacity. In our exercise you'll be running two different tests. In the first test, the subject will breathe normally for a few breaths, and then they'll be asked to take a deep breath in and then breathe all the way out. And then they'll resume normal breath again. From this test, we will be able to measure the subject's tidal volume, inspiratory reserve, expiratory reserve, and vital capacity. And from these numbers, we can then calculate their other capacities. In the second test, we will have the subject breathe normally for a few breaths, and then we'll ask them to breathe in maximally and then forcefully and quickly exhale. With this test, we can measure forced vital capacity and forced expiratory volume. All of our data can then be compared to normative values. If you haven't read up on this information yet, then you might be feeling a bit lost with all this new terminology. So what I will do now is give you a quick tour of the Spiro Graham that shows many of the things that I've just mentioned. This picture is from your textbook, and along with its accompanying table can help you to understand all of the data that you will be collecting and calculating from your experiment. Your first experimental results will look very similar to this spirogram and hopefully will translate very easily for you. So let's look at some of the components. The smaller peaks represent normal breathing, and an upward deflection is inspiration and a downward is expiration. We see here that a normal inspiration is about 500 milliliters and a normal expiration is about the same. So tidal volume is said to be 500 mils. Let me highlight inspiration and you will see what I mean. This will be exactly how you figure out tidal volume on your experimental spirogram. Once we ask the subject to take a deep breath in, then we can measure both inspiratory and expiratory reserve. The inspiratory reserve is the amount of inspiration above tidal volume, and expiratory reserve would be the amount of expiration below tidal volume. Vital capacity is the total of tidal volume plus expiratory reserve volume plus expiratory reserve volume, which we can measure experimentally from high peak to low peak. And that should get you started with learning these volumes and capacities. What I want to do now is show you how to use your BioPack Reader software to take these measurements. But first, let's figure out what the normal value for vital capacity would be for an example subject. Our subject is Jared. Jared is 5 foot 10 inches tall and he's 25 years old. Let's look at our equation for vital capacity. And you'll find this equation on the first page of your data sheet. Now, as I mentioned, Jared is 5 foot 10 inches tall. That's 70 inches, and that would equal, 2.5 centimeters per inch, 175 centimeters. So we're going to plug that into our equation here, and we're going to put his age in as well, and we're going to do some multiplication and some subtraction. And we'll come up with a normal value for vital capacity for Jared of 4.95 meters.